Namaste everyone. I welcome you all for today's session on data mining and machine learning techniques and algorithms. Data mining and machine learning, they go hand in hand. And we had seen in our last lecture about the two types of models, predictive as well as descriptive. Generally, the descriptive model techniques and algorithms are used for machine learning purpose, whereas the predictive modeling techniques and algorithms, or you can say the predictive modeling design or any data mining algorithm is designed using predictive modeling approach. Why it is? Because in data mining, you're going to dig the information and knowledge from the existing data. That is also DBMS, database management system. But in data mining, the data set is large. So we are trying to predict the knowledge and interpretation or the information from the large data sets. Hence, predictive modeling technique is used for data mining. Whereas we are going to feed the machine with the head or make the machine a learning system. With the algorithms, we try to incorporate, and henceforth, since the machine's computation power is high, we get the same output which we would be performing manually, but in a much more faster and in an accurate way. Because after a certain exhaustive approach by humans, okay, error starts coming. That is why machine learning descriptive approach is used. What is the difference between techniques and algorithms? An algorithm is a complete description of how to correctly produce that output from the input, whereas a technique is a broad word for any kind of general approach that may be used to make progress on problems. It may also be the case that coming up with an algorithm to a problem requires combining multiple techniques. So as we saw in our previous lecture on the types of models used for data mining and machine learning, for the descriptive type of approach, clustering, association, sequence discovery, these are the techniques. Whereas for predictive modeling, classification, regression, and time series are the techniques. Whereas individually, each technique is classified with algorithms. So for example, for clustering, we use K-means and Kohanen algorithm. For association, we use a priori and GRI algorithms, right? So algorithm is a complete description of how to correctly produce that output from the input. So in K-means algorithm, we have a certain data set, and basically the size, the number of clusters is defined as 3, and then depending upon the formula equivalent distance, we calculate each data set with the threshold value. The equivalent distance, if it is the threshold value is matching to the first cluster, okay, the 3 clusters threshold value are decided, okay, from the programmer, and then the equivalent distance is calculated from 3 thresholds. The nearest threshold cluster is assigned to that particular data item, or the data item is assigned to that cluster whose threshold is very nearer according to the equivalent distance, right? So that is a complete step or a description how we are going to do the clustering. But in general, clustering is a technique because it is just a grouping of data. You can use n number of algorithms, okay? Every algorithm will have its own complete description, or you can say its own methodology, right? So even method and methodology, if you try to differentiate, method is one particular technique, okay? So that is algorithm. It can be interpreted. Whereas methodology can be combination of methods. So you can use combination of methods to perform your clustering. So you should not be just go ahead with one type of algorithm. Sometimes fusion of algorithms are also used where you have n variable type of data. So that suppose your data set is text. So you may, and you are going for text mining, right? So for text mining algorithms will be used. But ultimately, if it's your entire data mining project, you need to handle not only the text data, but also images. So some image processing algorithms would be used for clustering them, right? If there are graphics, then you need to use the graphics or the animation algorithms for clustering. So the point is here that your data set has a different variety of data, and henceforth you can use different algorithms for different type of data set, but ultimately they are the clustering techniques which we will be combining to have the clustering on your entire data set. So that is how you differentiate between a technique and an algorithm, and a method and a methodology. So going on with the clustering, as last time we had discussed about the K-means cluster, okay, you have to decide the number of clusters and then you select the random points. Say one point is selected. For example, if you create a cluster of faces, right? So as we know that faces also, through faces also we can predict a lot of things. So if there is a round face, okay, or there is a broad type of face, there is an angular type of face, there is a heart type of face, okay, heart shaped face, and all these different, there's an oval type of faces, and all these faces have a different characteristics. For example, a person with broad face has got a leadership qualities. The person with oval face is very sensitive and but easily adapt to changes. Okay, a heart shaped person is very sympathetic person. Okay, so similarly characteristics are defined with the shapes of the face itself. So you can randomly select one shape as one cluster, another shape as say centroid of another cluster. So for example, this is the cluster of say round faces, oval faces, angular faces, uh, heart-shaped faces, and then whatever other faces will come, you will try to match, right? So this is how the another example which is given here is that as per the age, the dose is divided. So if the age is less, so dose will also be less. But here the dose will increase with the same age if the severity of the fever is more. If you are trying to say about the fever dose, then if the fever is high, maybe the dose has to be more for the same age and vice versa. So we had seen about these techniques last time in our previous lecture when we had discussed about the models. Okay, but today we are going to discuss with the algorithms. So neural network is one type of algorithm which is used, which uses the parameter adjustment system. So threshold is nothing but the, you need to adjust according to your cluster characteristics. For example, the threshold is for the round face, right? All the faces should have the approximate round faces, and you can calculate the round face with the help of the scale also. Okay, for example, according to the years, if the years are small, those people are they do not grasp information very easily. You have to repeat the information to those people. If you just give them a lot of material at one instance, they become confused. Whereas with the years with high big years, okay, or high years, those people grasp knowledge very easily. So how you can create the threshold? High years means from the eyebrows, if you try to match. Okay, so high years generally start from the eyebrows and end near the nose. Okay, whereas the small years, they start below the eyebrows and still they end near the nose. So this can be the threshold. So similarly, if some unseen faces come, you need to calculate the threshold. What is the position of the starting of the year? Is there, it is near the line of the eyebrow or it is down the eyebrow? So this is how you need to adjust. So these are the adjusting systems which you can use using. So that means you can classify, okay, the small years and high years with the help of neural networks algorithms. They are interconnected elements because see here, what was the interconnection? The ears and the eyebrows. Maybe eyebrows is different, and right now we are not touching on the analysis of the eyebrows, but still during the ears analysis, we still want the measurements of the eyebrows and the nose also. So that means we have got a lot of interconnected elements for the classification as well. Okay, Train the net on the training data set. Of course, that we already discussed in our 2 lectures, 80-20 rule. We test on the 20% data to, we train the 20% data to get the, then test it on the 80% data, and likewise. But the drawback of neural networks is that it can deal only with numeric data. So the diagram is as follows. You've got an input layer, you've got a middle layer, okay, where all the functions are defined. In C or C++, whatever the modules we try to analyze for one particular objective, those are called functions. So we encapsulate different instructions for one particular objective, and that is called a function. And you can encapsulate even the members and functions together, called as class in object-oriented programming. So these can be functions or class rather. And this is an output layer, which is basically on the client side. So if you go through the Java architecture, also known as the MVC architecture, okay, MVC is a 3-tier architecture. So one is the model, MVC, M is for model, where data is kept. View, V is view, view is whatever is seen to the user, and that is over here the output layer. Whereas the C is the controller, which handles the between the model and the view, and it is handling the business logic as well, and that is the business layer. So if you correlate these neural networks in terms of MVC architecture, okay, this is the M layer, that is the model, that means the data layer from where the input will come. Okay, this is the business logic layer or the controller layer, okay, which is in between the view, the client, and the data backend. You can say this is the backend and this is the front end, and this is the business logic or the controller. And output layer is the view layer of the MVC architecture, which is directly associated with the client, what is visible to the client. And then as per the output, what is expected to the client, okay, you design the prediction model, right? So for example, if your output layer is prediction through the years, so obviously your input will be the position of the years, right? And business logic will try to analyze whether it is a small layer or a big small years or high years as per the inputs given. It may be in the form of images, it may be on the form of position of the years, right? And similarly you will get the prediction. So as we said, the small years, they do not grasp information very quickly, and big years, high years, they have the capacity to grasp the knowledge very quickly. They are very quick learners. So same that depending upon the output. If your output is according to the face shape of the face, then definitely your input will change, right? The face, you will not only require the years position, but you will require the entire face structure rather. And you can have another algorithm to decide how to calculate the type of the faces, right? So here you can have both things. First task will be the measurements to calculate what type of faces it is, to classification. So classification algorithm also will be included in the neural networks, right? That's why neural network is also termed as technique and also termed as algorithm also. And another type of step you will be requiring is, after you classify that which type of face it is, then you need to classify the decision on those shapes, that yes, if the shape of the face is round, then what is the characteristic? If shape of the face is oval, then what is the characteristic? So this is how, depending upon the output layer, your input layer changes, and depending upon then the input and the output, the controller decides the business logic. So this all goes over to the prediction then. Okay, so this all, whatever the entire thing, data goes to your prediction logic, where you can use the prediction model techniques, right? And then you have a feedback learning model. That means you try to test it on the actual data. When you get, and then after you get the actual data, you assign weights, because now you are getting the data as per the output expected. If it is not as per the output expected, then you need to remodify the weights. So you assign the weights as per the feedback or the output from the prediction model. If why it is called adjust, because if it is not as per your output, you need to adjust it again accordingly and again perform the entire transaction until and unless you get your expected output. So this all training is happening on 20% of the data. The moment you get expected output, you run this entire prediction module on your 80% of the data as a training set. Okay, and you can see the results. So this is a feed forward type of neural networks where you do not have the back forward. Like over here, you are having a back forward, right? So it is coming back and you can adjust the weights. But a feed forward type of neural networks, it just goes ahead. Okay, you cannot adjust the weights later. So very loosely based on biology, inputs transformed via network of simple processors. So this is more of a what you can say centralized system. See, we have got a single tier system, we have got a 2-tier, and we have got a 3-tier. So the previous thing was a 3-tier architecture, but this is a single type of architecture, right? So in single type of architecture, the load is on everything on the same server. Okay, and if it got shut down, the entire system gets crashed, and that is why it is very loosely based on biology. Processor combines inputs and produces out an output value. Yes, the weights are also defined over here. The only thing is, after the output is there, you cannot readjust the weight. Okay, once it is final, it is final. But as you can see, whatever the benefits are there from 3-tier architecture compared to 1-tier architecture, same things over here also, the drawbacks of feed forward neural networks as compared to our previous 3-tier neural network functioning is there. You must have heard about the COM and DCOM components. Okay, so why MVC architecture became very popular after Java? Because you have a facility to create components. Components is that you deploy it in any project. For example, login and password is the page, authentication page, which is being used by all the emailing services, say Hotmail, Rediff, Gmail, Yahoo, and so on, right? So that component can be purchased or can be sold to n number of clients who are working on the emailing systems or maybe who require authentication services. It not just needs to be deployed. Similarly, you can create different type of components which you can sell it, and that can be used as one of the module in the project. So component is not the entire project, maybe a part of the project. Okay, so reusability is very, very important if component is being designed. The more reusability is increased, the more components business value also increases. So similarly, we have got different types of neural networks, right? So as you can see, there is no layer in between. Okay, just an input layer and an output layer. Okay, you have one layer in over here in between, right? You have got a mesh type of network over here. So just trying to say that depending upon what type of project what type of input and output you have, what type of complexity can your program handle, what type of complexity is needed, depending upon that, you can design your neural networks. So neural networks, it can be used for predictive modeling. So as said earlier, it is a predictive modeling technique and algorithm. Now you might have understood why technique and algorithms are go hand in hand. Okay, because in neural networks we also require classification, right? So that's why it's a combination of algorithms. That's why it's called a technique. Okay, whereas if you just use a simple neural network concept of input, middle layer, output prediction model, and the output feedback, then probably it is an algorithm. Similarly, you have coherent networks. It is a type of neural networks that is used for clustering. So there is a algorithm called as coherent clustering over here. So it's a precise method. Now you understood what's an algorithm. So if I say that it's a coherent clustering algorithm, so these are the steps how you perform clusters, okay, how you define clusters, how you predict clusters, right? But if you incorporate coherent clustering networks in neural networks, then it becomes a technique rather. So what is the drawback? The drawback of neural networks is that it's a completely black box. Okay, you do not understand what is this prediction model, right? And that's why neural networks is also called as black box. That's why most of the people try to avoid this technique. So key difficulty is that the problem is that the difficulty to understand, because it's not, the technique is not visible, right? And the relationship between weights and variables are also complicated. This you have to perform manually and it may go wrong. So you have to again go back, then readjust. So this is quite a lot of times not practically possible. And that is why the training time error decreases as the power of the training size increases, because the weights have to be adjusted according to the data. So the more the data is going to be increased, the more readjustment you have to do, because weight is assigned to every data type of set. Okay, so it is really a time consuming task also. So training time also increases because of this, right? So there is a significant pre-processing of data often required. Hence, it is avoided in most of the cases. The next type of algorithm and technique is decision tree. Okay, so trees, as we all know, it's a data structure. Since you are a computer engineering student or a BCA student, data structures is a part of your syllabus. Even if you have not learned about it, for a layman, trees is something that you've got a root node. Then you've got, for example, if you have learned object-oriented programming language, you've got a parent, then you've got a child. Okay, then child again has got child, right? So when it ends, okay, when the leaf node of the tree is, okay, it is called as a leaf node. A leaf node is a node which doesn't have more childs, right? So you have got siblings. So similarly, every node has its own feature. But why you are creating trees, as discussed one example earlier, that uh, for decreasing the complexity and overburdening, and for performance efficiency increasing, we divide the university into different departments. So that is nothing but tree. Again, in departments, we have got different classes, years, okay, first year, second year, third year, and so on, right? In departments also, we have got sub branches, right? For example, in School of Engineering, we have got computer, mechanical, electronics, ENTC, and so on. So this is nothing but a tree structure. So can you have two branches or more than two? It depends upon you. Totally depends upon your design. So each node is called as a decision node, right? So every node you need to finalize what it is giving you as an output. So intermediate nodes also give you some outputs. So decision trees are of two types: classification, which is used to predict categorical value. Okay, so you can design your trees as classification and also as regression trees. So what is the difference between both the trees? Classification trees is used to predict categorical values, and regression trees are used to predict continuous values. Now, what is the difference between categorical and contiguous? In a categorical variable, the value is limited and usually based on a particular finite group. For example, a categorical variable can be countries, year, gender, occupation. A continuous variable, however, can take any values, for example, integer to decimal. For example, if we have the revenue, price of a share, etc. Okay, now we will see here, if this is an example of categorical value. So if age is less than 35, so this is continuous, it can be categorical also. Why? Because this is a range, right? We are not saying that if age is equal to 35, there is a range over here, and when it becomes a range, then it is a contiguous value. So if age is less than 35, if it is said that age is equal to 35, then also the dose is defined, you can see that. And if it is of a range, then also you can decide the dose. That means this type of tree, okay, it can be used for categorical values prediction as well as the contiguous values prediction also. So if age is less than 35, dose and dose is less than 35, then yes. So what is this yes? So this dose less than 100, that means the dose is less, okay? And yes means that you can consume this right away without any doctor's prescription, because it is quite in the range, right? Or you can say that the fever is just of weakness. But if the dose is greater than 100, it's given in the prescription at the back, then probably no means you cannot you should not consume it. Consult a doctor and immediately action to be needed. Same case is with the age greater than 35. Since here age is greater, the dose will also become greater. So if dose is less than 60 for 35 age and plus, this is normal, right? So that's why it is just a weakness. But if it is greater, then probably you can predict that you should consult a doctor. So it is just an example. You can remodify this as per your output variable. Okay, now what you prescribe, this yes and no can change as per your output. Okay, that's why this is not given over here. Just the meaning of this is that this depends upon your interpretation. Whatever you want the output, the interpretation of y and n will be different. Similarly, another example you can take it, that if it's the outlook is sunny, then you can say that it's humidity. But if its humidity is say less than 75, okay, it is safe, you can play. But if it is greater than 75, you should not play. Okay, similarly, if the outlook is overcast, it's absolutely fine, you can play. If the outlook is rainy, and rainy can have even windy, so if it is windy, then better uh, false windy means it is not windy, it's rainy but it's not windy, so still you can play. But if it is a windy, that means you have to take care. For example, the cyclone today, whenever I'm recording this lecture, okay, today it is expected that the cyclone is going to be there in the evening, and for 2 days all the power is also shut. So the thing is that we need to take care. Okay, so at that time it is recommended that you should not go outside to play. So this is also an example of decision tree, right? And again, this is categorical as well as continuous, because we have got a range of value greater than 75. There's no limit given over here, right? And this is 0 to 75 or maybe minus, so there is also a range specified, not exactly a value like hard computing. So it has also got some, see, every algorithm has got certain advantages and disadvantages. Now this is up to you what your project demands. Okay, if your project is able to handle the limitation of this particular algorithm, but the advantages which is provided by this particular algorithm is very, very required for your project, then you should go for this algorithm in your research. Okay, you can also compare this algorithm with the other recent work. As I said, that you can download some papers, some research already done, certain modules, certain white papers. Then you come to know that maybe some better version of this algorithm has come into picture. But if you see that this is quite handy and all the advantages is useful for you and the limitations can be overcome by your project, then you can definitely decide that this XYZ algorithm or the technique is best suitable for your project. So the advantages of decision tree is as follows. Models can be built very quickly. Even school students, you know, if you give them some categories, they will be able to design a decision tree. Okay, it's as simple as that. Suitable for large data sets, easy to understand, gives reasons for a decision taken, handle non-numeric data as well, which was the drawback of the neural networks, which is handled by decision trees, and minimum amount of data transformation. Limitations leads to an artificial sense of clarity. Trees left to grow without bound take longer to build and become unintelligible. Okay, so the moment a tree starts growing, okay, then it becomes very, very complicated to understand. May overfit the data. Sometimes, you know, it's difficult. You need to have certain values between 0 to 40 also. Okay, you want some values between 40 to 30 also, then 30 especially for 60 to 75 also. So if you try to decategorize the simple humidity in 10 values, then again this is very complicated. Okay, so in certain scenarios, then the trees become complicated. But otherwise, if the data is quite categorical the way it's given here, then it is quite simple to implement. So that is why it may overfit the data. Okay, when it will overfit the data, when you will have 10 arrows over here. Okay, you can't fit over here only. So then algorithmically also it becomes then complicated. But then if the data is too large, still at times, okay, people try to use decision trees, because for here you may have 10 arrows, but for algorithm you may have only 4 lines per arrows. But if it's going to be run on 2 lakhs of data, it's quite feasible to write a 4 into 10, 40 lines of code. Algorithms used for splitting are generally univariate, using single independent variable at a time. Obviously, if we are using this humidity, this is a single value. Okay, at a time, only one value is being used. If you want 7 parameters on this humidity, then again it will become complicated. So in certain such scenarios, decision tree has its own limitations. Now going to the third type of technique, that is rule induction. Now, extraction of useful if-then-else rules from data based on statistical significance. So as the name suggests, rules. Okay, so in your programming language, in C, C++, you have learned about if-then-else, nested if, nested loops, right? Ladder, if-then-else ladder, okay? And switch case, that is also an advanced version of if-then-else. Rather, it is a there is a drawback in if ladders. Okay, in if ladders, there is a lecture of mine on switch case in C++. You can go to that video. We have explained that if there is multiple ifs, what happens that first if condition is true, then also the rest if conditions are evaluated. So unnecessarily computing time increases. But if you are using a switch case, what happens if the condition is true in the say third switch, then it ignores all the other switches, right? So the accuracy and the time, the computing time of CPU is also decreased. So efficient use of if then else can be done with the help of switch case. Completely a machine driven process. Okay, because if then else is there, so even the else part would be handled by the machine itself. Can discover very general rules which deal with both numeric and non-numeric data. So as you can see, it is covering the advantages and rather overcoming the limitations of the earlier two techniques, that is neural networks and decision tree. So rather this rule induction seems to be better. Translating the rules into a usable model must be done either by a user or a decision trees interface. Right, so you need to create first a decision tree. For example, if you have created a decision tree here, so you can obviously write an if then else very simply. So if outlook is equal to sunny, then again a nested if the sunny and humidity is less than or equal to 75, then you should play. Else, if outlook is equal to overcast, then you can play. Else, if outlook is equal to rain and windy is equal to false, then you can play. Else, if outlook is equal to rainy and windy condition is equal to true, then you cannot play. So here decision tree after you make, it's very, very easy to convert it into rule induction technique using if then else. So if car is equal to Ford and age is equal to between 30 to 40, then defaults is equal to yes. Weight is equal to 3.7. Similarly, it's very easy to use the if then else. And as a programmer, okay, we have learned in different programming languages. No programming language is gone without the if then else. So some of the highlights related to rule induction is look at all possible variable combinations, compute probabilities of combinations, but it is expensive because you have to handle if as well as the else part. So for over here, if we saw how many if did we took, if, another if, then else part. another if, okay, then here another if, then another if, then else part. Okay, so there are approximately 7 if conditions you need to satisfy. So for a simple tree there were 7 ifs, so you can consider if for a long complicated database. Okay, so obviously it is expensive. Expensive means over here the computational power of the CPU, because for every if and else, okay, the condition has to be checked from all the data values. So if there are 2 lakh data values, the if condition will be checked on all the 2 lakh data values. That's why it is said to be expensive. Okay. Limit calculations to those with sufficient support. That is why if you want it to be less use less CPU computations, then you should limit your calculations. So you have to design your if then else in a very thought processing manner, the way you design your DBMS queries. For example, DBMS, if you go to my lectures, there is a lecture on Cartesian product and subqueries. So what is the difference? It's very easy to design any query by using a comma operator. It's a separation between 2 tables when you try to combine and try to take the results. But internally, a lot of computation power is used when you use the comma operator, because internally Cartesian product takes place. Okay, but when you use joins, in joins, or subquery. Subquery is another technique where you take a subset, okay, and since you take the subset, the combination permutation is less, and hence the data space and the computational power also required is less. So for a simple query, if you use optimization techniques, right, you may be decreasing 60% of the computation power at the back end. So when moving on to larger combinations of variables, then the support decreases dramatically. That's what we discussed right now. So there is another technique and algorithm called as KNearest Neighbor. Okay, and it is what? It is a classification technique. So to overcome the drawbacks of decision trees, the another classification technique is described here. So it decides which class to put a new case in, right? So you need not take the entire data set. You, as said that in C and C++, what is the difference? There is more security, there's more privacy, you can have inheritance in C++, so that the reusability increases and you need not repeat the functionality which is already proposed by its parent class. So similar, that's what is the concept of this classification technique. Okay, so as classification, the word class of the C++, the same concepts come here into picture. Criterion is to find a maximum number K of neighbors having most similar properties. So when we saw about the clustering and the K-means clustering, it is something similar to that. So it assigns a new case to the same class to which most of the neighbors belong. So as we said, we formed 3 clusters. Okay, one of round face, one of triangle face, one of heart shaped. Okay, so 3 clusters are formed. If an unseen face come, we will see the parameters to which face it is more nearer, and then we will fix it into that cluster. For example, a face comes with a broad face, but we do not have this category out of 3. We have only round face, we have triangular, we have heart shape. So obviously it will come to the round face, because broad face will be somewhere similar to that. Okay, so that is where you need to, whatever new unseen case comes, okay, you have to identify having most similar properties. So this K-nearest neighbor classification technique is used for clustering as well. So set of already classified cases. So as said earlier, first you will take 20% of the data to classify, and that will be your training, right? And then you will test it on the 80% of the cases. How you will do? Decide how to count the neighbors. Assigning weights to the neighbors may give more weight to nearer neighbor than a farther one. So I'll repeat, decide how to count the neighbors, right? Assigning weights to the neighbors may give more weight to the nearer one. Okay, so you will find out the equivalent distance. So the equivalent distance weight value, distance would be less, that more the distance is less, the more the data set, the new case is nearer to that cluster. But here weights are assigned, and in weights category, the more the weight is, the more it is nearer to the cluster. Okay, because even if you see a very fat person from near, he seems to be fat, but if the same fat person is standing 10 kilometers ahead, you don't seem to be that fat, right? Same concept is here. If the weight is more, that means it is nearer. For example, it is a visualization technique. The aeroplane is so big, but from the sky, it looks like a sky, right? Because if the distance is far, we don't understand the weight of the uh, aeroplane. Same concept has to be considered here. So this is already discussed in our K-means. So same K-means concept is used for our K-nearest neighbor model. Okay. So B's nearest neighbor is A, right? Out of all these, A is nearest because the distance is also less. And all these neighbors are of A are closer than B. And all these are closer to A rather than B. Okay. But this is by visualization you can see. But in computer, you need to calculate this distance. Either you use the equivalent distance method or you assign weights. So developing a nearest neighbor model. So if you want to create this model as said here, that how to assign weights or the distance, how to assign that which is nearer, which is farther. Okay. So what does near mean computationally? Need to scale variables for effect. How is the voting handled? Okay. So for this, we use the equivalent distance method. So weights, age is equal to 1, dose is equal to 0.2. Distance, this is the threshold value we have decided. Okay, this is as per, you have to take the knowledge from the expert to identify these threshold value, okay, from the domain expert. And once these thresholds are decided, then you calculate the distance using the equivalent distance method. So what is the formula? Okay, the weight assigned to age and the actual age plus the weight decided to dose and the actual dose. So if voting 3 out of 5 nearest neighbor, so K will be 5. So confidence will be 1.0 minus D of V. So this confidence will be 1 minus D of V. V is voting 3 out of 5 nearest neighbors. Okay. So the total number of neighbors is 5, out of which 3 are near as per our visual sense, or maybe after using this equivalent distance, we found that we did the sorting. Using these formulas, we will calculate the equivalent distance for all the 5 data sets. Okay. And we see that 3 are near and 2 are far as per the threshold decided. That means the values which were created after calculating the distance, they are greater than 1 and they are greater than 0.2. But if they are nearer to 1 and 0.2, okay, then we say that they are nearer. So out of the 5, it's just that here the example is given. Okay, I'll take another lecture separately, especially for calculating the nearest neighbor. We will take an entire data set, okay, maybe of 10 values, and I will tell you how to calculate this distance in the form of machine learning, also in the form of data learning. So that will be the coming lecture, which I will be going that in detail. But right now, since this is a fusion of all the algorithms which we are discussing today in brief, just try to understand that 3, after computing this distance, 3 were found to be near considering these threshold values, and we then calculated the confidence. How did we calculate the confidence? 1 minus the values, that is 3, and then divided by the total number of values, that is 5, and then that value becomes our confidence. So more the value, less is the value of the confidence, okay, the more that value has a more approximity in the cluster. So just to summarize the comparison of the algorithms today, which we discussed in brief, the K nearest neighbor, since the comparison is there, we will try to see what are their drawbacks and their advantages. So if we consider the K-nearest neighbor, this was the last one, okay, and since it is most frequently used, quick and easy models tend to be very large. Whereas in neural networks, it is difficult to interpret, can require significant amounts of time to train. For rule induction, it is understandable, need to limit calculations. And whereas decision trees, it is understandable, relatively fast, easy to translate into SQL queries. If you ask me as a programmer, I generally first design my model using decision trees, and then I try to convert it into either subqueries or using joins, and use efficient use of if then else, okay, and then also incorporate rule induction. So the technique combination of algorithms I'm using in my projects is decision trees and rule inductions. Neural networks is, I try to use it, but since it is a black box, okay, lot of times interpreting the weights, really the training time is increased and you don't get the desired results, then again you need to go back, which is really practically not possible. At times you get exhausted, okay, and confused in between. And the K-nearest neighbor, of course, we are going to discuss it for theory purpose, but calculating the equivalent distance at times does not give you accurate results in my projects basically. But yes, for some type of clustering algorithms, I do use the equivalent distance calculation, which we will be seeing as an example in our next lecture. So accordingly, these algorithms, as discussed in our previous lectures also, are designed using supervised and unsupervised. So supervised means the training which we are doing on 20% data would be totally seen data, right? And testing also would be on the seen data. But for unsupervised learning, the training is also on the unseen data and testing obviously would be on the unseen data. But generally, I use a semi-supervised learning where I do training 20% on the seen data and I do testing on the 80% unseen data. So I just try to modify this algorithms for in a semi-supervised mode. And at times, even regression trees also are used because they help us in defining the contiguous values, because every time you cannot have the categorical values, right? So we will be discussing there in our upcoming lectures. For today, I think just you need to understand these 4 basic techniques and algorithms used in machine learning and data mining and summarize with the comparison of each, so that you are able to identify which type of model, which type of technique, and which type of algorithm you are planning to use for your project. Thank you very much for your patience listening. If you have any doubt, okay, you can mail me or drop a message in the comment box or on our group. Thank you once again.